All right, so one thing, at least like one pattern to be aware of is just like everything goes through a subdomain. So um, actually, I have to think about that. Got the stream on as well. That's can't listen to that in the background. I should see if I could put on a something. See if that works. All right. Not that. It's hot. Well, let's see. Oh, there's a little bird over there on the other side of the. Oh, my dog's over there. I think it could be fun to figure out how I could like take a picture real quick and then have it let like in the stream or something, so I could like show it to people. I don't know, something. All right. Well, I think it's just me, but going to try and share a few things. So I have a site, eb.ndexr.io, And one of the things that I'm working on is, well, so there's an organization called Compute Canada, and they came up with a way of, well, maybe it actually makes more sense for me to like try and explain it through my my experience as a developer. Um, and one of those things is like, so there's this layer between the user and, like, well, so say you have an app or you have a problem that you need to solve. This is my huge water bottle, by the way. You have a problem, for example, at the first company that I worked for. The problem was we're an advertising agency and we have customers that give us money because we create digital marketing campaigns for them. And there is, a whole industry where people are, spending tons of money on online advertising. Um, and the particular problem was, um, sorry, I get distracted because I'm in the backyard. Um, Basically, one of our products was an optimization, and we basically, the claim is we can look at who, or we can look at the process of the customer on the websites, and going to your page instead. And what we do is we look at how things are best performing between Facebook, between Google, the trade desk, um, and we can move money around based on the performance of your campaign, and then like you know better retarget and set up certain ads and stuff. Um, and so that process involved people all across the company doing different things that you need to try and coordinate and organize. Um, and so one what I did when I first got there was learn the learn the optimization that they had, and basically it was like at the moment just like some Excel spreadsheet that people were putting together from data they were getting um, from those platforms, like through a UI. And so as far as the structure of the teams go, um, you had at least 5 people in the data engineering department. Um, you had 3, sometimes 4 front end web developers, and that was already in place. Um, but the company had hired this guy who just got out with like a master's in statistics, and like he was there taking those Excel spreadsheets and he was converting them into R code. R, the letter R. Like there's the C programming language, there's the R programming language, not ours as in mine. I always feel like funny saying that. Um, anyway, so I was backing him up, and at the time there was there was an API framework called Deploy R that they were like it was, I guess, to some extent either the project eventually, um, or the code itself, but there was like an incentive to move off of the Deploy R framework, um, and to start using Plumber, which is, um, well, was at the time like just coming out. Um, and so and so Plumber. So I was basically learning the existing optimizations, and then I wrote an LP, a linear program that went into um, that Plumber API. And what we were doing is pulling the data from the data warehouse of those metrics, um, crunching them, looking at the existing budgets and the constraints, and reallocating those budgets through a web framework called Meteor, which, if I remember correctly, um, is what kind of inspired Shiny. Um, and so, the we worked in parallel with that, um, with all of those teams, and like they would build the UI framework while we would work on the API, and we would like agree on what the response would look like, and where it would be stored, and then they would pick it up, and um, you know basically there's multiple pipelines. There's um, you know a QA and a prod, and it all looks nice and neat. I mean, it didn't feel nice and neat, but like in hindsight, like that all of that came together was, I think, pretty cool. Um, but that was a lot of people, and there's a bird up there. So that was a lot of people involved, and every project I've worked on since, well, th- there's a whole there's a whole thing actually. Well, so we move everything over to Plumber, um, but then the question comes up, um, do we build or buy? And um, because that was related to Ponza Connect, that would well our Studio Connect, um, which would be like a streamlined process for deploying our applications like our plumber API, so that the React team could pick it up. And the thing that I was really interested at the time is like working on that project. Do we build or buy um, Posit Connect? And I talked with some people around the company, and um, there was this guy Duffy that I worked with that taught me what a load balancer is and said Nginx is something that you should be able to like do that with. Um, because at the time, and it actually seems a little bit silly now, was like this idea of like we can't scale without Posit Connect. Um, and the project itself was an internally facing app that maybe like three people would be running on at a time. Um, but I took the API and I used Docker Compose, I used Nginx, and I was able to, within, I can't remember, but it was like, within a second to like have like 900 responses or something, which is ridiculously fast. Um, but it didn't come with like a guarantee that things would work ever. But like in hindsight, like now, those are just like the basic tools. Um, like you need to know something about, or need to have known something about containers and Nginx. Um, losing my train of thought. So, but the point is we ended up paying Posit Connect. I think it was 25,000 Posit, our studio, $25,000 a server to run the software, and within about a month's time, I'd figured out, assuming that I had the authority to do so, to be able to spin up something that like to build something that could have avoided that cost, right? um, and so that was pretty inspirational because it's kind of like, oh well, I mean, like they're obviously like this is obviously a skill that's in demand because we just paid my entire year's salary for some software that I felt like I just built. Um, and it wasn't the same, but like it was pretty convincing to me, and so that's where I've focused my entire career almost, is like thinking about delivering domains and sites and applications to people in the most convenient way possible, and using Shiny as a framework that is kind of foundational to that process. Um, but as time goes on, there what you find is that like the problems never go away, but like what I was trying to reach for in that was like this combination of speed and reproducibility and accessibility to who needs to have access to those things. Um, and like really spent a lot of my time focusing on how to build those, and my primary language being R, I centered a lot of like work around that. So so you think about all of those pieces and building an application, and what that basically looked like was you would put like a code into your web browser and or like a URL, right? And the web browser would return like JSON or something. And it would have basically like, here's the dollar amount to put into this thing over here and this thing over here, and they could tinker with it. So, um, if they said, well, it says the budget should be this, but we really want to like take away over here. If you took away over here, it would push it elsewhere. Um, so so building a API is kind of like the center of all of that. um, but then you go further, right? And you say, well, but like I don't really have the at the time I didn't really have the ability to like build a website fast. But Shiny was like giving me the tools to learn how to do that. But I spent my time like focusing on web development and trying to think about that problem, but then be on the other side where, okay, well, now I need to like understand how to, you know, create a site which allows the person to be able to put those inputs into the algorithm and get those results back. Um, and then you do that, but then you realize that, in order to be able to do that outside of a company, you also have to understand like the security and all of that. But then once you understand and you could get people into your site securely, um, it's like a whole. I'm just like tearing apart this stick. It's like a whole other thing where once you have someone come into your site, um, how do you control their flow through your software, and how do you control their flow so well that you can know that only that person on the other side of the line is actually the one doing the thing and can provide you payment for the thing, and then you could actually like return that back. um, and so all those problems, but then so now that you've written all of that software, um, which is like kind of metaphorically every company in existence at this point, like now that you have all of the software, um, and I think just because I've been in the pharmaceutical industry, like how do you rebuild this thing from scratch, and how do you prove that, and how do you prove that you could rebuild this thing from scratch, and then 5 years from now, you know, turn it back on and basically minimize the foundation of error. Um, and there's like basically all of code is thinking about that conceptually all the time. Um, but like, just see if there's cards. Um, oh, whoops. So one way of managing that problem has been something called a container, which is basically um, it's like a way of starting up a little mini computer within a computer, is um, which has worked for a lot of things. But one of the problems that you run into with more regulated industries is like that, yeah, that concept of reproducibility, and also um, and also on the other side of that problem are people that need to be able to solve problems. Um, and and one thing that comes out of that are basically new and innovative ways of, or maybe it's not new, I don't know, it's new to me, but basically, okay, so it's going to get technical, but I think that like it, it's going to have to. But one thing that I'm interested in is this concept of validation, and within pharma, um, you'll see a lot of other companies talking about it. So I've seen, Posit obviously talking about it, Jumping Rivers talking about it, Absalon talks about it. Um, a Taurus is another one. Um, they all, we're everyone is in on this concept of validation. Um, oh, there's a blue jay. That's perfect. Um, so, so what does that even mean? Um, and I think that after all this time of thinking about it, that I think validation is maybe just maybe just high level proving that it does what it does. Um, and for and for and also within pharmaceuticals, there's this idea of, at least within computing, or like on the server or whatever, you have like root access, and then you have user access. And one tension that you notice in the software engineering community is this idea of like there's IT, or there's the guy who actually like owns the infrastructure, and that's like a super powerful place to be in. Um, but if you can't own the infrastructure, and if you can't get root, then you can only write programs in the you know in the in the software that is provided to you, and that is a really annoying place to be if you are a developer, um, because you're a developer and you want like the latest and greatest of all of the toys and tips and tricks or whatever, Um, but you can't actually like use it because, well, you have to have this like system library, and if you're not the guy who goes and installs that, and does it in a timely manner, then you, for example, like there might be a new plotting library that you want to use, or there is a database that you want to have access to. But um, but in order to be able to do that, you have to have X, Y, or Z. Um, and so one of the things that you kind of want to be able to do is to figure out, well, how to make everyone happy, right? So you have, for example, within a pharmaceutical company, you have, you know, 300 data scientists who all like, need to be able to run a particular statistical analysis, um, or they need access to, this level of, you know, compute or whatever. Um, so I guess fast forward and today, having gone from like being the developer to, within the pharmaceutical space, moving a bit more from like developing on applications to developing applications that scientists are using. What what seems to be the case on like really big supercomputers, um, or basically on like, you know, um, well, I think that brings us back a little bit to Compute Canada, where they have a cluster of servers across the country in Canada, and they have, you know, hundreds. I don't know how many, people, but a lot of people needing access to compute power. Um, but they can't just allow everyone in the country to be able to install whatever they want on these big computers. So so how do you, for example, build RStudio for a government contractor to, you know, to access to access, um, well, I guess in this sense, like, you know, Compute Canada, or in Canada. Um, how do you how do you build the thing that allows them to get into RStudio server with the the number of cores in memory, and, whatever they need, and then do their job, and then like, you know go off and do whatever else they need to do. um, and so what that looks like technically, at least the foundation, is there is, and this is just like the answer. You compile everything from scratch and you build from the kernel. And then you basically, once you've compiled everything from scratch, and you've built for a particular kernel, if you can distribute that file system or those files efficiently across the network to other HPCs and keep them in sync, then, you've and if you can prove that from the ground up, then as far as the the code being stable and reproducible, you've kind of started about as low as you can possibly go, um, and then having proved that from the ground up. Um, and so, one thing that's interesting about this is that you don't need root privileges to actually start this process. Um, the reason why is because Gen 2 prefix, which is the operating system, um, Gen 2 prefix is built to be basically like an internal operating system that you can compile from scratch in user space, SSH into your server and just like, you know, start compiling. Um, you compile everything through Gen 2 prefix, or you compile your operating system from scratch. So basically, you're trying to rely on as little as possible from root in order to get everything you need to be able to install the software that you want to use, even though you can't access root. And so if you actually, you know what, this is where I can share my screen, and I can say, let's see, uh, Gen 2. Actually, I have prefix.ndexr.io. Um, so, but we can look it up. Mm-mm-mm. Somewhere around here. Right. So prefix is a way of installing a Gen 2 system in a non-standard location designated by prefix. Like, here's your basically like root folder for the shell. And then, it's right here in big, yeah. If using a campus server with an old version of Linux and only have limited access, prefix would give the user to be able to run newer things, and the ability to use Linux inside operating systems such as Mac OS and Solaris. Yes, but it also means having a process in which you're um, beginning to control the foundations of validation or the foundations in which the things can break long term, depending on how you do things. And whenever you have thousands of people with tons and tons of you know software needs and all of that, like, I think generally speaking, you need to be able to just pull open the folder and run it. And whenever you compile and you build everything from the inside, um, and because you're building an operating system in a non-standard location there, um, assuming that you follow all the rules, and you don't bleed into grabbing environment variables from the host or anything like that, then you should be able to take all of that within that folder and copy it onto another file system with the same compiler, or the same kernel, um, and just be able to run the script again. Which is cool, because now you basically have, okay, here's like this S3 folder of whatever, and I can just copy it over and keep these supercomputers in sync, um, and actually CVMFS, which it's like the CERN virtual file management system. Um, they're the ones that like wrote the software that takes care of that syncing process in an efficient way. Um, but in between that is um, so this is like kind of the pathway um, to to building this validation layer. Um, I might I might say okay, just keep in mind like I'm talking about the subdomains here. Um, every time, at least here, we're swapping actually between different sites. Um, but each one of these sites is actually being um, it's going straight back to the same Shiny app. So no matter where you go, it just looks like a different application, but it's not. Um, Now these are all separate modules and they have their own separate repos, but all that process is more or less automated. And like this whole process where you can go to a maybe I can turn my face off. Okay, I did. Yeah, you can go here and have an agent. You can go to the terminal for that particular page. Um, you can go to the VS Code application for it on the file system. But going back to the HPC stuff and validation. Um, right, so if you're interested, you could read through these things, but there's kernel.ndexr.io, and you can start at hpc.ndexr.io. Um, but this is kind of the process, right? So you have the kernel, you you compile prefix, and then easy build is a way of managing the compiling of um, of scientific software. And you can look here, easy build. Um, but easy build is it's a nice way of, well, I'm going to tell you it's not easy to build anything with easy build, but um, but if you had to do it another way, if you because what this is going to give us is the ability for users to launch, or us users or ourselves to be able to launch specifically, say, X version of RStudio from 10 years ago, um, and be able to like know that we can do that going forward. And for the installation of those things to not get stuck, um, or not bog down other distributions of software. And so Easy Build will basically give you a process for, in this case, I've built from scratch R 4.6, 4.5, 4. These, and they all have their own dependencies, right? So if you're building R has um, you know OpenBLAS for matrix calculations, right? And so these higher level programming languages still rely on even lower level libraries, and so it's kind of like libraries all the way down until you get, well, I don't know. I don't know what it ends. Um, Maybe that's like LLVM or something, but maybe that's just another. I have no idea. But here, now I've got R built from Gen2 prefix within this file system, and I now have basically like an R binary that I can move into other locations and run this version of R. and um, and I can open this R, and then I can swap out this R with that R just from the terminal. So what that looks like, um, let's see. We go to the terminal here. What are we doing here? Maybe I don't want to break this, but let me just do this. God. Okay, here we go. Yeah. So if I go into, no, let me just stop. Okay. Actually, I can do here. So module spider R. And you can see I have R 4.5, 4.5.1, 5.3, 4.6. Oh, yeah, not 5.4. And so I could run MLR, and that would give me this version of R. I can run MLR 4.5, and I've got the latest here, and I think you get the gist. But in this sense, now you're swapping out R versions within the user terminal, which is only going to benefit you, especially if you can just copy this process over. Um, because this is how if that scientist adds this module, then the assumption is that we're proving that this is going to remain and this is going to stay forever. Um, and so long as you need that data to be reproducible, then you've you've stored that process in writing, basically. Um, and that's the other thing is these file systems, they're open, and data and stats are delivered, and then they're stored. And but you have to be able to run them again. And so that whole process gets you to reproducing, say, R. But then the next thing that I'm working on is the the compiling of all R packages on CRAN and Bioconductor, and building them through prefix so that you can mass distribute the entirety of Bioconductor and CRAN to everyone through CVMFS. Um, so so that's kind of where I'm at. Um, and then along the way, my whole workflow is kind of built in from this process here. So if I go to the front page and I look at it, and I don't know, I say, I don't know what I would say. I don't know. I can come in here and basically like talk to Claude on the terminal for that domain, and update the site just from talking to it, looking at it, and swapping things out. Um, yeah, so that's about where I'm at as far as you know the validation stuff goes. But then from there, it like, for example, jumping rivers, they have, I guess, a tool called litness or something, but like they're talking about validating individual functions. And like, and so I'm thinking like, what what would I, if I've done the prior, which is built everything from scratch, from compiling from the ground up, CRAN and bioconductor and internal packages, and keeping all those things secure internally, um, then like, if all of that is reproducible, what what does it mean to validate a package which will always exist, and like the result will always be based on the version of that package at that point in time. Everything below the package itself is immutable. Then what does it mean to validate on top of that, like, five functions out of 60, because you're not going to use the other 55. And like the first thing that comes to mind is maybe like, there's dependency risk, but that dependency risk only exists if you're going to continue to use it, and it like is not very, I don't know. It I'm just not sure. Um, the only other concept that I can think of would be like validating that the statistics that are coming out of the package are correct. Um, and there are people in the pharmaceutical world which, you know, using both SAS and R, um, wanting to be able to prove that, the result in SAS is the same result that we get in R. That would be, one some sense of validating. At this point, though, I think what you would do is you would just talk to an agent and say, "I have the SAS code, I have this R code. Let's validate it." To at least, say that I understand the statistics, right? Um, there is a red-winged blackbird over here. I haven't. Oh, there's another birdie. I should put the birds on. They're more interesting. Look at that. Yeah. So I don't know, but I do think that there's a lot of value in building software from Gen 2 prefix, and going through that whole like easy build process. Um, he's behind the. Oh, that's a pretty bird. I don't know what kind of bird that is. Oh, I have this Merlin bird app. Um, but basically, like, ndexr is a it's software that I basically use to do everything, these days. I too need that to be able to be built, like the CLI that I have with ndexr, the API, um, the way that it's built. I'm basically trying to get it completely built through here, alongside with that process, to be able to just package this entire system for, um, you know, building multi-domain, multi-repository systems, from one folder. Um, so this whole like system used to be, um, you would log in, and or at least now it actually kind of looks nice. You log in, and there's not a whole lot here, but there's basically other places, within ndexr that I have. So account, a little bit self-explanatory, but here, this is showing like my AWS spend, which is probably ungodly this month again. Yeah, I mean it's not too bad. Um, Here's my AWS spend. Every person who logs in, who puts their credentials in, would see this stuff. They could build off of what I'm working on. These are all, obviously there's some work I could do here. This is probably because it's me. That's where you can create a domain. And then there's this AWS, which this was the original build, which is like, you come in, you pass your API or your AWS credentials, you come in, you launch a server, and then now you're managing your servers, right? And in here, I mean, this is like, this is the server that this is running on. So ndexr.io is this one server, that you can see here, that I could, obviously start, stop, and everything else. But I actually haven't touched this very much recently. But I could improve this. But if you theoretically wanted to like come in and start a server on AWS and have my code do it for you, then you would be able to do that, and then access it, and it's got like our studio and stuff on it. But I'm thinking I'm going to swap this out, and what I could do is, instead of this launch server, we go back to the process of easy build and RStudio server and all that, right? So within ndexr, instead of, on an HPC somewhere, right, you can copy all this code over, and then each person can log in and start their own, um, you know instance. And it's okay. So originally people would have been like, they come in here, they start a server, and then they can SSH into the server. It's got like RStudio, it's got some Shiny apps, and it's hooked up, and it kind of tells you this is how you start the Shiny app, whatever, right? And puts the domain in there so that people could actually like get going. Um, but then but then so that's me, an individual, basically giving people the ability to provision servers, on behalf of them. In the pharmaceutical world, it's, I'm provisioning you this allocation of memory in on this cluster over here, and you pick RStudio, you push the button, RStudio starts, VS Code starts, whatever. Um, and it runs within your user space on that server, ideally built by EasyBuild. And so Open on Demand is a company, or not a company, but they're an organization that basically builds that like front end interface process. Um, but but I think that I have something nicer and cleaner here, and it's similar. It's similar, but basically where people will come in here, they'll. I don't think I'm even sharing the screen. I don't think that I am. Right here. So they would come in and basically start a server, um, and then here's the server that I was talking about. Um, yeah, but instead of swapping a server out or starting a server, instead they'll start a start their R version on a secondary HPC server, and if someone needs something, then they can start a session on that server. But otherwise, it could be off. And so there's other ways of like sharing resources, and for each of those, it just depends on whether or not you're going to start one small computer, or start a really big one and have people share it. But I think oh, it's an interesting problem that I've thought a lot about. So um, yeah, so me right now, I guess going through this easy build, trying to get all of at least a couple R, Python, and Rust versions going, and then building up CRAN and Bioconductor from there, and then validating that I can publish from you know cvmfs.ndexr.io, and then what I'm hoping to see is the ability for somebody to basically hook up to my server and then like reproduce, ndexr immediately. I think that would be wildly cool. And then we can just all share servers or something. Who knows? um, Building VS Code. Okay. Yeah. So that's what I'm up to. I think I'm just gonna call it good and then go back to birds.